Hey guys, and welcome back for another lesson on solving equations. My name is Miss Danielson, and today we're looking at two-sided equations. That's when you've got a variable on both sides of the equal sign. I hope you joined us for our previous lesson on solving linear equations. That was our introductory lesson to solving equations, and we're going to be building on that today. So if you missed it, I'm linking it down in the description box below so you can check that out before we get started. Let's start today's lesson off with a reminder and clarification about variables. As we've seen before, variables are the letters or symbols that we use in algebra to represent some unknown value. We very often use the letter x in algebraic expressions and equations for values we don't know. And the value of x may vary from one situation to the other. So although x may have a different value from one question to another, for example, x plus 2 equals 8, while in another example, 5x equals 15, so in separate examples, the variable might have different values. However, the same variable in one single question must represent the same value. So in the example we saw on the title page, 3x plus 8 equals 2 brackets x minus 4. We see two different x variables in the same equation. Those x's must be the same value. Now, once again, let's go through the steps we've seen before for solving equations. But to solve two-sided equations, we're going to need to include a couple of extra steps. Step 1 will always be the same. We are always solving our equations vertically, that is, top to bottom. So we line up our equal signs on top of each other so we can clearly see what's happening on the left and right side of the equation. Step 2, to solve an equation, we want to get the variable on its own. And to do that, we look at what's been done to the variable and we reverse those operations to undo it. Step 4, we make sure that the equation is balanced. So whatever we do on one side, we need to do to the other side as well. Step 5 and 6 are really just reminders rather than steps. The order of terms must be maintained. So when we're rearranging this equation, when we're undoing operations and moving terms from one side to the other, make sure that the term that we're moving comes after the terms that are already there. Point number 6, in algebra, remember that the multiplication signs are often left out. So this is just a reminder that a term like 4a, for example, is the same thing as 4 times a. And finally, step 7 was to always check your answer. When you've finished solving an equation and you've got the value of the variable you're looking for, substitute that variable back into the original equation to make sure that it calculates out as it should. Now that's how you solve a normal equation. But if your equation has variables on both sides of the equal sign, there are a couple of steps that we need to remember as well. Step 1b. First, you want to simplify both sides of the equation, if possible. Then step 1c, move the smaller variable term to the same side as the other variable term. Now we'll explain that with a couple of examples in a minute. Then step 1d, group your like terms so that there's only one variable term, because you will have grouped your common variable terms together. Now, including those 3 extra steps there, you should be able to solve two-sided equations the same way we've previously solved single-sided equations. Now would be a good time to hit pause and copy those steps down before we get into the rest of the lesson. Or if you prefer to see a couple of examples first, just don't forget to come back here to copy these steps. So for example 1, we can clearly see that we've got the variable a on the left-hand side as well as on the right-hand side of this equation. I've put a short form of my steps and reminders over here on the right-hand side so we can remember them as we go through this. Step number 1, we want to line up our equal signs. Step number 1b, simplify both sides. Can I simplify this side at all? Can I group those terms together? No, because they're not like terms. This side either. So on to step 1C. Move the smaller of the variable terms. Looking at our variable terms, that's the terms with the letters in them. So 3A and A. Which one is smaller, 3A or A? Hopefully you'll agree with me that 1A would be smaller than 3A's. So I'm going to move this term from the right side to the left side. How am I going to do that? Well, think about how we undo an operation. A is being added to the 8 here. So I want to get rid of that A. I'm going to subtract the A from both sides. That will get rid of the A on this side. And to keep the equation balanced, I'm subtracting A from the other side as well. So on the left side, I'll have 3A plus 7 minus A. And on the right side, I'm left with just the 8. Now I can simplify by grouping our like terms. So my like terms, which I was trying to get together, are my variable terms. 3A minus A is 2A. So I have 2A plus 7 equals 8. Now notice that I no longer have a two-sided equation here. I now have a single-sided equation, and I've finished those extra steps that I mentioned before, so I'm ready to continue on solving as we've done before. We want to get the variable on its own. So to get that A by itself, think, what's been done to the variable so that we can undo it? The A is being multiplied by 2, and then that answer is being added to 7. So working backwards, let's undo that. Let's get rid of that 7. Opposite of adding 7, we'll subtract 7 from both sides. Let's just simplify that. 8 minus 7 is 1, and we're working vertically, so we'll write the 1 on the right-hand side underneath the 8 minus 7, and we still have 2A equal to 1. I want that variable on its own. So what's happening to the A? It's being multiplied by 2. To undo that, we'll do the opposite. Let's divide by 2. If I divide the left-hand side by 2 to get the A on its own, I must also divide the right-hand side by 2. So A must then be equal to 1 over 2. Remember, fractions just mean divisions. 1 divided by 2. So if A is equal to a half, let's check that answer. If A is equal to a half, we should be able to substitute that value in for A into the original equation. I always use brackets for this, so I don't accidentally think that this is 3 and a half. This is 3 times a half. 3 in front of a letter means multiply by 3. So 3 times a half, that would be half of 3 is 1.5. And half plus 8, that would be 8 plus 0.5, 8.5. So we've got 1.5 plus 7 is equal to 8.5. Is that true? Is that equal? 8.5 equals 8.5. Yes, it is true. Now, don't get confused, as I know a lot of students do. This was just our check. What we're checking is if our answer, A equals a half, works. And yes, it does. So the solution to this equation is A equals a half. Let's try an equation with brackets now. Again, this is still a two-sided equation. You see, I've got the variable B on the left-hand side of the equation, as well as the variable B on the right-hand side of the equation. First step, same as always, let's line up our equal signs. Step 1B, simplify both sides. Now, in the previous example, I couldn't simplify the expression on both sides. Here, I couldn't do B minus 8 because they're not like terms. But 3 bracket 2 plus B, this could be simplified. I can expand this bracket out. So multiply the 3 through by all terms inside the bracket. If you need a lesson on expanding brackets, I'll link it down below for you. So first I'll do the 3 times the 2, which is 6, and then I'll do the 3 times the B, which is 3B. So I've simplified the expression on the right-hand side. I no longer have brackets. I've done all the calculations that I can do for now, because of course 6 and 3B are not like terms. They cannot be added together right now. So I've done step 1B. Step 1C, move the smaller of the variable terms. So looking at the variable terms, the terms with the letters in them, 3b and b, again, I hope it's quite clear which one's smaller, 3b or 1b. Clearly the 1b, right? So I'm going to move this b from the left-hand side over to the right-hand side. Think about how we're going to do that and be very careful. The minus belongs to the 8. That b is positive. On the left-hand side of the equation, we've got b minus 8. We could just as easily write minus 8 plus b because that b is positive. And if I want to get rid of that positive b, I'm going to need to subtract it from both sides to keep things equal. So once I've gotten rid of the b on the left-hand side, I'm left with negative 8 there. And on the right-hand side, I needed to subtract b as well. So I've got 6 plus 3b minus b. Now I've got all of my variable terms on the right-hand side. Let's just go ahead and group those like terms. So simplify. 3b, take away b. That would be 3 minus 1. That's 2. So that's 6 plus 2b. The left-hand side has not changed. Still negative 8. So now I have an equation which has got a variable on just one side. So we can continue solving this equation as we have previously done. Step 2, get the variable on its own. I want that b alone. What's been done to it so I can undo it? The b is being multiplied by 2 and then added to 6. So let's work backwards to undo that. So get rid of the 6 first. The opposite of adding is subtracting. That will get rid of the 6 on this side, leaving just 2b. And on the other side, we'll have negative 8 minus 6. That's negative 14. So negative 14 equals 2b. We still need to get that b on its own. So again, think, what has been done to the variable? What's the 2 doing to the b? It's multiplying. How do we undo multiply? We divide. So let's divide both sides by 2 to keep the equation balanced. So 2b divided by 2 is going to leave the b on its own. And negative 14 divided by 2, well, that's going to give us negative 7. So negative 7 equals b is the same thing as b equals negative 7. We've got our solution to this two-sided equation. But we should always, always, always check our answer. Whether you do it mentally or you write it down, you must check your answer. And with two-sided equations, it's a lot easier to check if you write it down. So given that b is equal to negative 7, is the equation going to be equal? Let's substitute negative 7 in for b on both sides of the equation. So negative 7 minus 8 and 3 brackets 2 plus negative 7. Negative 7 minus 8 is going to be more negative. That's going to be negative 15. And 3 brackets 2 plus negative 7. Let's work out what's inside that bracket first. 2 plus negative 7 is the same thing as 2 minus 7. That's negative 5. So we've got negative 15 equals 3 times negative 5. Is that true? Does that work out? Yes, it does. 3 times negative 5 is negative 15. So our answer is correct. B must be negative 7. Once again, don't get confused with your check and think that your answer is negative 15. We worked out our answer over here. Let's try another example, this time with brackets on both sides of this two-sided equation. We can see it's a two-sided equation. We've got the variable c on the left side and on the right side. We'll still start this the same way by lining up our equal signs. Then, step 1b, simplify both sides if possible, and it is. Although we can't do c minus 8 because they're not like terms, we can certainly expand the bracket through. So multiply the 3 by the c, 3c, and multiply the 3 by the negative 8, negative 24. We'll do the other side at the same time. We'll do the 5 times the 2 is 10, and the 5 times the negative c, negative 5c. Next step, we'll move the smaller of the variable terms. So looking at our variable terms, 3c and minus 5c. Yes, that sign is included when we talk about the term that follows it. This is a negative term, and negative terms are always smaller than positive terms. So negative 5c will definitely be smaller than positive 3c. Let's move that negative 5c. Now to move that negative 5c, it's subtracting from the 10, and the opposite of subtract, we will add. 3c minus 24 plus 5c is equal to the 10 on its own now. Grouping our like terms to simplify that, 3c and 5c, so we've got 8c minus 24 equals 10, and we now have a one-sided linear equation. We just need to get the c on its own. What's been done to the variable? Let's undo it. C is being multiplied by 8, and then 24 subtracted off. So let's work backwards. Let's get rid of that minus 24 first. Opposite of minus 24, plus 24. That will get the 8c on its own. So we have 8c equals 10 plus 24, which of course is 34. To get the c completely on its own though, how are we going to get rid of that 8? A number in front of a letter is multiplying, and the opposite of multiply is divide. And c will be equal to 34 divided by 8, which is 4.25. So we've got our solution to this two-sided equation. It's quite a complicated two-sided equation with these brackets. So let's do our check, writing it out. Given that c is equal to 4.25, will this equation be equal if I substitute 4.25 in for c on both sides of the equation? Let's see. So 3 brackets 4.25 minus 8. Is that equal to 5 brackets 2 minus 4.25? Let's start by simplifying what's inside the brackets first. So 4.25 minus 8, that's going to be a negative number. That'll be negative 3.75. And 2 minus 4.25, that's going to be negative 2.25. So we've got 3 times negative 3.75. Is that equal to 5 times negative 2.25? You can use your calculator if you need to. Both sides will be equal to negative 11.25. So if both sides are equal, the equation is balanced when c is equal to 4.25. Yes, that's our answer. C is equal to 4.25. Let's try an example with fractions now. Something to keep in mind, don't be afraid. Fractions are just divisions. So to eliminate a fraction, just think about undoing a division. Opposite of divide is multiply. So we'll just multiply the denominator across to the other side. Let's start by trying to get rid of this 2 in the denominator of the left-hand fraction. What's happening here is 3 plus 4d. That answer is being divided by 2. So we can move the 2 to the other side of the equation by multiplying this whole side by 2. Before we should do that though, remember, let's line up our equal signs. That will get rid of this division by 2 here, because 3 plus 4d divided by 2, then multiplied by 2, will just be 3 plus 4d. And 2 times this fraction over here is just going to be 2d divided by 3. We don't multiply both the top and the bottom of the fraction by 2, because that would just give us an equivalent fraction to what we had above. It would not be the same thing as doubling what we have above. So I've eliminated one of those fractions quite easily there. I just moved the denominator to the other side and multiplied by it. So let's do the same thing for the right-hand fraction. Let's move the denominator. See, this 2d is being divided by 3. The opposite of divide by 3 will multiply by 3. So multiplying both sides by 3 will get rid of this denominator here, leaving just 2d on the right-hand side. And on the left-hand side, we better use some brackets to make sure we're multiplying the whole thing by 3. Right, now we have a two-sided equation. We got rid of the fractions. But we still have variables on both sides. So, following the steps, we've already lined up our equal signs. We've already started here. Let's simplify both sides. 2d can't be simplified, but this side with the brackets, we could certainly multiply this through. So let's do that. 3 times 3 is 9. 3 times 4d is 12d. So 9 plus 12d equals 2d. Next step, move the smaller of the variable terms. And let me just explain to you why we're always moving the smaller of the variable terms. If I took the bigger one, so 12d, over to this side, I would have to subtract it because this is add, and then I'd end up with a negative term over here. 2d minus 12d would give us negative 10d. I don't particularly like working with negative terms whenever I can avoid it. So let's move the 2d from the right-hand side to the left-hand side. To get rid of something that's there, we're going to want to subtract it away. So minus 2d from both sides. That's going to leave me with nothing on this side. And nothing is a number. What number represents nothing? 0. So we've got 9 plus 12d minus the 2d on the left-hand side, and we've got nothing left on the right-hand side. That's 0 on the right-hand side. Let's simplify this, grouping like terms. That's going to be 12 minus 2, that's 10d. We want to get that variable on its own though. So getting that variable on its own, what's happening to it? It's being multiplied by 10 and then added to the 9. Going backwards through that, getting rid of the 9 first, the opposite of adding 9. Let's subtract by 9, leaving just 10d on the left-hand side, and 0 minus 9 is going to be negative 9 on the right-hand side. So 10d equals negative 9, but what is d? We need the variable completely on its own. Right now the 10 is multiplying by the d, so we'll undo that by dividing by the 10. So d on its own must be equal to negative 9 divided by 10. Any value divided by 10, I hope you're not reaching for a calculator. That's just moving your place values. The 9, which is in the units, is going to end up in the tenths position. That's negative 9/10. Notice that that's the same thing as a decimal as it is as a fraction. Negative 9/10 and negative 9 in the tenths position. So we've got our answer. D is equal to negative 9/10, but that was a lot of working. I wouldn't trust myself to just move on to the next question. Let's check it. So if D is equal to negative 9/10, is the equation going to be balanced and equal? Let's substitute negative 9/10 into the equation and let's work that out. On the left-hand side, first let's work out what we've got in the numerator, starting with the multiplication. Remember, BEDMAS, multiplication comes before addition. So 4 times negative 0.9 is negative 3.6. So we've got 3 minus 3.6 over 2. And on the right-hand side, I went directly to the division. Negative 0.9, a negative divided by positive 3 will give us a negative answer. And 0.9 divided by 3 is 0.3. Let's just keep working through the left-hand side to see, are they equal? 3 minus 3.6 would be negative 0.6. Is negative 0.6 divided by 2 the same thing as negative 0.3? Well, 6 divided by 2 is 3. So 6/10 divided by 2 should be 3/10. So negative 6/10 divided by 2, yes, that's negative 3/10. So our equation is balanced. The left side is equal to the right side. So our answer is correct. And remember, this is our answer here. D is equal to negative 0.9. This was just our check. Now, how are we doing so far? Are we ready to get on some practice? Let's give it a go. For question 1, look carefully. Some of these equations should be fairly simple for you to solve. Some of them aren't even two-sided equations. So you're just going to need to get the variable on its own. But if they are two-sided equations, remember, simplify both sides, get your variables together by moving the smaller variable term, group like terms, simplify, and solve by getting that variable on its own. For question 2, as you can see, we've got some questions here with brackets. And once again, some of these questions are easier than others. Some of them aren't even two-sided equations. For question 3, as you can see, we've got questions here with fractions. Try to get over that fear that we all have of fractions. Fractions are just divisions, and the opposite of divide is multiply. Now go ahead and hit pause, copy the questions, work through your answers, showing you're working vertically, equal signs lined up. When we take it up, I'm much more interested in seeing you're working than seeing that you have the right answer. I hope you had a chance to hit pause, because here come your answers. For question 1, first we'll move the 11, minusing the 11, simplify, then we'll move the 4, dividing by 4, and our answer. Question B, first we'll move the 7, we'll minus the 7. Notice the negative belonged to the 3b and it stayed there with the 3b. Simplify, then we'll move the negative 3, which is multiplying by the b, so we'll divide. Question C, first we'll move that 7 and be careful because the minus belongs to the a. If you want to hit pause at any time as I'm taking this up to make corrections, please do that. So if the minus belongs to the a, the 7 is positive, we will minus it. Now the a needs to be completely on its own. I don't want to know what negative a is, I want to know what a is. But keep in mind that negative a is the same thing as negative 1a. So to get that a on its own, that negative 1, what's it doing to the a? Hit pause if you want to try it for yourself. It's multiplying, so we'll divide by negative 1. For question D, finally we've got a two-sided equation. Let's move the smaller variable term, simplify, and we've got our solution. Question E, again, let's move our smaller variable term, simplify. Now let's move the 9, minus it. Now let's simplify. Now let's move the 3, divide by it. On to question 2, dealing with these brackets, let's start by expanding them out. Now let's get the q on its own, starting by moving the 4, then the 6. Question B, expand that bracket out. Move the smaller variable term. Group like terms, let's get that variable on its own. Question C, brackets on both sides. Let's expand both of those brackets out. Move the smaller variable term. Group like terms. Now let's get that variable on its own. Question D, expand those brackets out to simplify both sides. Move the smaller variable term. Group like terms. Get the variable on its own. Question 3, on to the fractions. Remember, they're just divisions. So the opposite of divide, multiply. Opposite of divide, multiply. Opposite of multiply, divide. 3C, be careful because the x is the one that's doing the dividing. Always multiply the denominator across. Now get that x on its own. The opposite of multiply, divide. Opposite of divide, multiply. Move the smaller variable term and get the variable on its own. Opposite of divide, multiply. We can do both at the same time if you like, or one at a time, whichever you prefer. Expand those brackets out. Move the smaller variable term, group like terms, and get that variable on its own. 14 minus 14 is 0. That's not a problem. 5 times u equals 0. What's u on its own? The opposite of multiplying by 5, divide by 5, and 0 divided by 5 is still 0. Now, how did you do with that? Did you remember to do the checks before we took it up? If so, great, but look carefully at my working. Does your working look similar to mine? Please leave me a comment down in the comment section if you're unsure if your working is good enough. Otherwise, if your work looks like mine, you've done an amazing job. Well done. Keep practicing, and I'll see you soon.